Hi everybody, we're going to go over example 5 of section 3.5, the law of sines. We have that a pilot is flying over a straight highway. He determines the angles of depression to two mileposts, 5 miles apart, to be 32 degrees and 48 degrees. We're asked to find the distance of the plane from point A. So we'll just go ahead and label the plane as point C. So the distance between the plane and point A is now highlighted on our diagram. We'll label that as B because it's across from angle B. So we have a triangle, but we don't have any angles given. We can work around that by using the fact that we have two parallel lines and a transversal, which just means a line going through them. So alternate interior angles are equal. So the 32 degrees up top, we can also say the 32 degrees inside our triangle. Similarly, with 48 degrees, that's a transversal through parallel lines. So now we have two angles of our triangle. Awesome. To use the law of sines, we're going to need an angle and a corresponding side. We don't have either of those yet. So we do have the side 5 miles, and we can figure out the angle C pretty easily. So C is going to be 180 degrees minus the two given angles because all three angles of a triangle add to 180 degrees. So we get that our angle C is 100 degrees. Great, now we have a corresponding angle and side, so we can use them to find B, which was the distance from the plane to point A. The law of sines says that sine of 48 degrees over B is equal to sine of 100 degrees over 5. We can cross multiply. Then we'll have B sine of 100 is equal to 5 sine of 48 degrees. Then to solve for B, we're going to divide both sides by sine of 100. So we get B, and then we can enter this into our calculator, make sure it's in degree mode, and we'll get 3.773, which we can round to be 3.8 miles. Cool, that's how the law of sines will be used in a application type problem. Now we're asked to find the elevation of the plane. So the elevation is if we go straight from the plane straight down to the ground, which would create a 90-degree angle. Now, since that bottom from A to B is now cut, we can't assume that that's 5 miles. So from A to B is 5 miles, but we're not worried about the whole triangle anymore. However, we do still know that B is 3.8, and we still do know our two given angles. So let's utilize those. H is the height of the plane, so we can label that on our triangle. Now notice that we have a right triangle. Yay! We get to use SOHCAHTOA and all those great properties that we spent so much time working on. All right, so now we want to know what trig ratio can we use if we have an angle, the opposite, and the hypotenuse. There we go. So the answer would be sine because sine is opposite over hypotenuse. So we can set up the trig ratio. Sine of 32 degrees is h over 38 because that's the opposite over the hypotenuse. To solve for h, we're going to multiply 3.8 to both sides. So we'll get h is 3.8 sine of 32 degrees. Then we can put that into our calculator and we'll get 2.01 is equal to h. We'll just round that and say 2 miles. So we get that the height of the plane is 2 miles.